In this video, we're going to find values that make a rational expression equal to 0. In number 1, we want to evaluate the following expression for the value x is equal to 3. And in A, we have 4 over 0. And since we don't have any x's, we can't plug 3 in. But 4 over 0, we're going to say is undefined. And it's undefined because there's a 0 in the denominator. In B, we have x divided by x minus 3. So we'll plug in 3 on top, divided by 3 minus 3, which is equal to 3, and then 3 minus 3 is 0. And 3 over 0, again we have a 0 in the denominator, and it is undefined. And in C, we have 0 divided by 3 minus 3. So we're going to plug in 3 for our x, which gives us 0 over 0. And 0 over 0 also has 0 in the denominator, so we're undefined as well. In D, it says, what do you notice about the denominator in each case? In each case, we notice that the denominator is equal to 0. In E, we have what is the value of the expression when the denominator is equal to 0? And the value of the expression is undefined. For part F, we have what is the value of the expression if both the numerator and the denominator are equal to 0? So this is similar to part C, where we had 0 over 0, and we said it was also undefined. So this shows us that if we're looking for points where we're undefined, it doesn't matter what the numerator is doing, so we can just check where the denominator is equal to 0. Unlike when we were looking for when expressions were equal to 0, we had to check the denominator to make sure it wasn't 0. We don't have to do that in this case. In number 2, it says, based on the conclusions from example 1, complete the following. The rational expression p over q is undefined if q is equal to 0, if our denominator is equal to 0. And 3, we want to find all real values for which the expression is undefined. So if we want to find where the expression is undefined, we're going to set the denominator equal to 0, so x times x minus 3 is equal to 0. And this expression is undefined at x is equal to 0 and x is equal to 3. In B, we have x squared minus 9 divided by x squared minus 5x minus 36, and we're going to set the denominator equal to 0. And now I'm going to write this in linear factors, so I'm going to have x minus 9 and x plus 4 is equal to 0. And we can see that this expression is undefined at x is equal to 9 and x is equal to negative 4. So now we want to look at finding the domain of a function. And 1, we want to find the values that make the expression undefined. And then we want to state the domain in words or draw a number line. And then we want to express the domain in interval notation. So 4 says, find the domain of the function below, state the answer in interval notation. In A, we have f of x is equal to x minus 1 times x plus 1 divided by x times x minus 3. So these are the same problems we looked at above. So we know our denominator is 0 at x is equal to 0 and x is equal to 3. So these are where our function is undefined. So now we want to use a number line to draw this. So we're going to draw a straight line, and then we know that we're not going to include 0 and 3. So I'm going to have an open circle at 0 and an open circle at 3. And then I'm going to highlight all the other spots. I'm going to put some arrows to show that it goes to negative infinity and infinity. And then if we want to represent this in interval notation, we're going to have negative infinity to 0, union 0 to 3, union 3 to infinity. In B, we have g of x is equal to x squared minus 9 divided by x squared minus 5x minus 36. And we're going to set the denominator equal to 0, which we did above, and we found that we're undefined at x is equal to 9 and x is equal to negative 4. So now we want to draw a number line. And we're going to draw open circles around negative 4 and 9. So we have negative 4 and 9. I'm going to draw open circles around both of them. And then I'm going to highlight everything else. So g of x is defined everywhere except for negative 4 and 9. And now let's show that in interval notation. So we have negative infinity to negative 4, union negative 4 to 9, union 9 to infinity. And that's all for finding values that make your rational expression undefined.